Welcome back. Today's episode is all about you. We're answering your questions from the past week, and I'm coming off a training week that went really good. It was a full house plus one. A full house is eight technicians, and we had a guest instructor also. And it was a really fulfilling week. I think they all learned what they came to learn. And the really good weeks are, I learned just as much as they do. But yeah, I want to go follow up on some of the questions that were asked this week. And we're going to start with honest tool reviews. And he's kind of feeling stuck. He said that he learned Mitsubishi 10 years ago and never got to use it outside of training. And now he feels he's hitting a wall because everyone wants Alan Bradley. Here's the truth, folks. Ladder logic is ladder logic. And here's why I stress to y'all so much too. Well, one, find the one that's most common in your area, but then learn it in depth. So if you know Mitsubishi in depth, and when I say in depth, you've learned the instructions inside and out, it's not a hard transition to switch to Allen Bradley or switch to Siemens or switch to Omron. That's not a tough transition. What I see a lot of you do is you kind of skirt around the different brands and you're looking to fill resumes, and I can understand that, but you'll learn a little bit of Allen Bradley, you'll learn a little bit of Siemens, you'll learn a little bit of Omron, learn a little bit of Mitsubishi, but you don't have that core knowledge of any of them to really get you to that next level. So what I recommended for honest tool reviews is first go to our free online courses. Since you're, button heads, it looks like against needing an Allen Bradley qualification, start with our Connected Components Workbench course, mainly because it is going to use free software. And we want to just get you kind of started down the route of, are you sure this is what you want to do? So should install the software. I want you to learn how to use the simulator. The simulator, here's a perfect example of where a simulator is good. Because I know a lot of you got upset with me because I put out a video saying pretty much schools need to quit using them, but this is the perfect example. You think that you need to learn Allen Bradley, but all right, we need a little bit more there. So do a few lessons, start figuring out whether this is really what you want to do, and then we can start talking about some hardware to get you going. And in that same conversation, Paul McClanahan, he backed me up. He said he went from a factory laborer to a PLC guy. He already knew number systems from from his Atari 400 days as a kid, and yeah, he made the transition. He does cringe when people call him the IT, and he clarifies that he is not engineer. He is a jack of all trades. And don't look down upon the jack of all trades, because that's the thing when it comes to our industry. I mean, we do have certain roles where you really super need to be specialized, but we have a lot more roles where you need to know some about PLCs, you need to know some about pneumatics, you need to know some about mechanical, you need to understand all the aspects of the machine. Next, we had really a good question from it's a repeat question really from Caleb Collins, and it's on 4 to 20 milliamp scaling. And he said, why not just scale the raw range to a 4,000 to 20,000 and then divide it by 1,000 later to get your floating point? And here in the grand scheme of things, that 4 to 20 scaling that you're trying to do just adds almost nothing to the experience, and you're adding an intermediate step. So we're just gonna let's take a tank level, for example. So we're gonna put a pressure sensor in the bottom of a tank. The more water goes above that pressure sensor, the more pressure you're gonna get. There's 2.31 feet per PSI, and a real common pressure sensor will be a 0 to 10 PSI pressure sensor. That means on that 4 to 20 milliamp scaling, we're going to be 0 to 23.1 feet. So if you look at most of my scaling videos, really, it's about taking your raw numbers. And now we're just going to I got to throw some example at it. So I'm going to use a 1734 IE2C. That's a point IO analog input module. Its low number, its 4 milliamp number, is going to be 3277. And its high number, that 20 milliamp number, is 16383. So we know that low and that high. And then we also know the low and the high of what we actually want to display, 0 and 2.31. So now we can take and we can draw a line between those and we can plot any point on those. And that's your basic y equals mx plus b equation. It also matches up with your SCP instructions that, a lot of us don't realize is pretty much y equals mx plus b. And so by adding that intermediate step, first of all, you're changing the default units. And now you're adding a variable that we've got to guess about. I know I could go to the module properties and look it up, but I'm going to assume that you've left it at its default scaling of 3277 to 16383. I'm not going to guess that you changed that to 4,000 to 20,000, or maybe you changed it to, since we're 0 to 23.1, you've changed it to 0 to 23,100. I'm not going to think to look at that first. So you've just added kind of an unknown variable, but then you're converting it to the 4 to 20, and then you're coming out and you're converting it to something else. And so now you've added another layer to it from a troubleshooting perspective. And I think, you know, here's one of those situations where over time, most people recognize that equation that we go through in those videos. And so that's why I stick with that one. I always tell you, people are like, what's the best way to write a ladder logic? And I always tell you the most boring way that looks just like everyone else's. So yeah, that's what I would stick with on that one. Next, yes, I put out a video, and I probably should have put out this video years ago. I've been putting some videos out recently on how you can make a career change, how you can improve where you're at in your company. And the comments were just discouraging. I woke up one morning, I'm like, I got to make a video on this. And so I made a video really how Amber and I both quit our jobs 8 months pregnant with our first kid and started TW Controls with $100 in our bank account. And that has been a great video. You should really read the comments on that video and on some of the LinkedIn posts and various posts. There's a lot of good encouraging stories in there. For example, Michael Clark shared his story of the Short Pants Club, and it was a group of entrepreneurs who left their comfortable leadership roles to put their houses and their 401ks on the line. And he made a great point. As an employee, if you don't do a good job, you get a bad review. As a business owner, if you don't do a good job, there's a good chance you can lose your house. And kind of building on that, Nikki Gonzalez noted that many people simply can't wrap their minds around the level of commitment it does take. And I think that's probably the key piece to understanding is it does take a level of commitment that I shouldn't say most, well, I'll say most don't realize, but many are not willing to take. I shared in that video, a lot of people are like, well, how much time should I block off for vacation? Right or wrong, Amber and I did not block off time for vacation to start off. It was a long time before we had a vacation. In fact, if we had a vacation, if Amber wanted to go to the beach with the kids, I found work at the beach. That's how we did it. Alex Marcy, he really hit the nail on the head. Automation is a great equalizer. You don't need a silver spoon or a fancy degree. Many of the great minds in our industry barely have a high school diploma. And Matt Steele backed this up. He shared his pivot. Here's a great pivot story. 12 years ago, he went from banking software with a political science degree to programming SCADA systems. And yeah, there's so many stories like that. Gene Mark Lenore reminded us that even Apple and Amazon started out in the garage. You can do this. And I do have to say I appreciate Jordan Yates Brennan, who said it's wild that anybody ever doubted Amber and I. I do appreciate that, Jordan. And Kelly Battaglini. Kelly, I always get your last name wrong. I'm sorry. I'm sure I didn't get it perfectly there. Who highlighted the importance of balancing, the manufacturing and your work life. And I think that is a tough balance. That's probably podcast worthy itself, as Amber and I are 20 years into this. And sometimes I have to distinguish and remember the difference between Amber, my business partner, and Amber, my wife, because they're not necessarily the same person. Yeah, that I need to write that one down. That probably is a good one. But looking ahead to this week, we do have the A3 Business Forum, and I'm looking forward to learning, about the future, where the conversations around robotics and motion control. And, getting looking forward to seeing everybody in the industry, our friends. And I mean, really, I consider them part of our family and see where our industry's headed. Is to, for example, Kathy, Ryan, and Lauren over at FlexLine, they'll be there. So I look forward to talking shop to them. Amy over at A3, look forward to networking with you and just everybody. But hopefully, I'll come back with some great ideas, on how to make y'all, how to improve our industry more. And yeah, I did put out a I put out a puzzle for last week, which someone did ask, why didn't you tell us your favorite comment of the week before? Because I did that the first week and then I forgot to. And that's all it was. I'm sorry, I forgot to. By far the first or week before last, I put out a cryptogram. And yes, if you didn't know what it was, you surely thought that there was something wrong with me. And really, the winner of that one was Gregory Martz, who commented that I should not be smoking non-filtered cigarettes. And yeah, I do know what he meant by that. But yeah, if you looked at that post, it looked like I was on something, and someone else commented, "Thank goodness I thought you had lost your mind, but I just realized you're posting a puzzle." Also, this week, we did another one. We actually skewed some words. I won't say the words just in case you want to go look at it. And a lot of you did get the answer. If you don't know, if you haven't found it up by now, you may want to pause here if you want to go look at it first. But yeah, if you tilt your screen or your phone, then you'll be able to figure out what it says. And Daniel Castro probably gets the this week's comment suggesting that we go ahead and call Kids over to overspend on a vision system to interpret the image. And I really did enjoy though some of you that really took it a little too literal. Because yeah, I did have some issues with trending of it, what, 2 or 3 weeks ago. I was having some noise, and so it kind of looked like a trend line. And so many of y'all gave some great troubleshooting tips on how to diagnose noise on a PID trend. From simply, first of all, put it in manual and see if the oscillation goes away. Well, no, it's an image, so the oscillation wouldn't go away. And actually, Hortal, she just went full blown technician on us, and she suggested that we have the proportional band until a quarter of the wave dampening occurs, which I'll even was actually a PID wouldn't be a bad thing. But I think our lesson there is whether it's a stretched image or an oscillating valve, a technician's job is to change the perspective until the data makes sense. But folks, sometimes you just got to tilt your head 90 degrees. So that's it for this week. I hope to see some of you at A3 and hope to come back with some good info. And I'll be back next weekend answering your question. Have a great week.